So our question now is, how am I actually going to use all this stuff? How am I going to use this, or how or when? Okay, so we all talked about problem solving. I kept saying we use matrices to solve these big giant problems. And like a really long time ago, I talked about not being able to divide by a matrix, but we never even talked about why we would want to, or why we might be tempted to do so. So now I'm going to talk about it. One thing we're going to do is we're going to convert linear equations, or linear systems of equations, which we have solved already. We're going to convert linear systems of equations into matrices, or matrix equations. Okay, so the way that we do this, it's going to look a little funny at first, but it's super cool. Come here. Alright, so we've got something like this. And then 2x minus 5y equals -2. Like that. Okay. What we're going to do is we're going to rewrite this as multiplying matrices together. And the way that we're going to do that is we're going to create a matrix A from the coefficients in the system. Like that. Okay? So by that I mean, first thing we need to recognize, what's the coefficient of negative x? Remember, coefficient of negative x is -1. Okay, so make sure you got that. But other than that, I'm going to create a matrix called A, and I'm going to say I'm going to pull the coefficients off in the order that they appear in the problem. A. Like that. That's my coefficients, A. Then I'm going to create B. I'm going to create B. And we usually call it little b. From the, what do we want to call them, from the constants. So I'm going to make this little b equal to 4 and -2. Okay, so I'm going to create A from the coefficients. You don't know why we're doing this, that's fine. I've actually got to do an example to show you why we're doing this. And create this from the constants. And then we're going to write a matrix equation. And that equation is going to be Ax equals B. Now, if it won't bother you too much, I'm going to make this a C, because I think that's what your book does, now that I think about it. Ax equals C. Or do they? Let me go look. This is actually important. I'll look this up in your book. Nope, I was crazy. They do call it B, but they call it big B. Alright, so I'll make it look like big B. See, this is what you get. Here we go. So now we have this matrix equation. Now when we say X, technically this is what we mean. Alright? So essentially what I've got is I've got a matrix equation that says -1 times 3 to -5 times xy is equal to 4, -2. Alright, why did I say this? Okay, let's go ahead and do our hand multiplying. So you've seen this once, so maybe you don't exactly remember what we're doing, but we're going to take this row times this column. So -1 times x, 3 times y. So that's the first element. And then we're going to do this row times this column, 2 times x, and then -5 times y. And you have seen that before. You've Just probably went bozo for it. All right. And then by matrix equality, like we talked about recently, we can see that we have this. So that's our original. So we got back to the original. So what I'm trying to show you is that you can take something that looks like that, and as long as it's linear, so you don't have any squares or square roots or anything funky like that, as long as it's linear, you can plug it back. You can plug it back into matrices and create a matrix equation that looks like this here. So this is the same as that. Now you might say, well, I can just solve the little system originally just fine, and I don't want to mess with these matrices. Well, yeah, but if it was 100 by 100, you know, if you had 100 variables, if you had 1,000 variables, if you had 10 million variables, you would need to be able to solve these with a matrix instead of just doing it by hand. Okay, so let's go back and talk about this AX equals B. I want to get x by itself. So you might say, oh, I can get x by itself. I'll just divide both sides by a. No, we don't want to do that, right? We said that under no circumstances are we allowed to divide both sides by a. So the question becomes, how do I solve for x? You might say, I have no idea how to do that. Don't worry, we'll get there. How do I solve for x? Well, I said way back at the beginning of this lecture, we can't divide by a, but we can multiply by its inverse. So we can't divide by a, but we can multiply by its inverse. Okay? We can't divide by a, but we can multiply by its inverse. So I'm going to do this once for you, and you're never going to have to do it again because this is a general form. If I have ax equals b, I can multiply both sides by its inverse. Now notice I multiply on the left. Why? Think about it. Why is it important that I multiply by the same side? Again, I'm here on the left. Why is it important that I keep the order straight? Remember, when you're doing matrices, order matters. Okay? Order matters. A inverse B is not the same as B A inverse. They're not the same, so I can't just say, well, I'm just going to multiply, you know. You can't do this, because that's not the same thing, because order matters. I have to keep on the left that A inverse for this to work. Because what happens now is I have A times A inverse. We said anything times its inverse is basically the identity. And the identity is like a 1 for matrices. So we can just drop it. So there I've got it. If I have, so I've got this fabulous little thing here, A inverse B, and this works for everything that we're going to do in this section. It works for everything that we're going to do in this section. So, in general, if I can convert a system and find A and B, I can get the solution to the system by finding A inverse B. Okay, and this is actually ultra powerful and totally worthy of a bubbling and other types of enthusiastic regalia. That works for absolutely everything. If I can take a linear system and convert it into A inverse B, then I'm home free, and I have a fabulous, fabulous solution right there. So I'm going to go back, and I'm just going to copy our original problem because I'm afraid I'm going to forget it. Copy. I'm going to leave that there just so we can see it. Whoa, I didn't copy it. I did something silly. Alright, I guess I'll just rewrite it then because it's giving me a hard time. So let's go back to our example, which was, there I have it. Okay, I found my paper. X plus 3y is 4, or minus x plus 3y is 4, and then 2x minus 5y is negative 2. Now, if you're feeling a little down and out, I understand these last couple of days that we've been talking about matrices, this is probably stuff that you may have never seen before, unless you saw it in Algebra 2 in high school, you might have seen it, and it might be kind of, you know, far back in your brain and kind of crazy, but just come plod along, we'll get there together. Minus 1, 3, 2, and minus 5. And then B is 4, negative 2, like that. Okay. So now if I want to find A, or X, I need to find A inverse B. I need to find A inverse B. The way to do that is to go to my calculator, and I want to create a matrix. I think I cleared everything out a minute ago. I want to create a 2 by 2 matrix of A, which is negative 1, 3, 2, negative 5. And let's see, I want to create my second matrix of B, which is a 2 by 1. So it's 4, oops, not point, try this again, 4, negative 2. Okay, now if you want to find A inverse just for funsies, you can. A inverse, you can just go ahead and find it if you want, but you don't have to. Instead, if you want, in fact we already found that because that was a previous example, but if you want, you can just type this straight into your calculator. I can say A inverse times B, and I get 14, 6. So believe it or not, that's actually the answer to the problem. The answer to the problem, as stated, oops, that's not what I meant. The answer to the problem is 14, 6, in that x equals 14 and y equals 6. Do you believe me? Let's check it. Alright, I said I had negative x, so negative 14 plus 3 times y, does that equal 4? Got negative 14 plus 18, that equals 4, so the first one checks out. And then I had 2x minus 5y, so 2x minus 5y, is that equal to negative 2? We got 28 minus 30, and that definitely equals negative 2. So that is the solution to that system of equations. Now this should make you super excited, because now you don't actually have to solve 3 equations and 3 unknowns by hand and do substitution or elimination or all this other kind of stuff. Although it's good to know, because this only works for linear. This only works if we don't have any coefficients or square roots or anything like that. But look, isn't this cool? You can like solve anything now with matrices. It's super awesome. So let's do one more fancy pants example because it's fun. And I'm going to solve a 3 by 3 just to show off. So, say now I want to solve x minus y plus z equals 2. Negative 2y plus z equals 2. And negative 2x minus 3y equals 1/2. So I know it's kind of close to the end of the semester, so you know there's some people who are blowing off the last week of class, and when they get to the final, they'll be like, man, I can't believe I have to solve that 3 equation, 3 unknown problem. Well, guess what? You don't actually have to solve it by hand because I don't really care how you get the answer. I just want you to get the answer. So this is like your treat for like paying attention all the way to the end of the semester, is now whenever you go and like do your final exam and stuff, you'll have a kind of a shortcut for doing all those problems. So it's pretty cool, actually. So let's find A. A is going to be all my coefficients. So let's make sure I know what my coefficients are. So the coefficients for the x is 1, minus y, the coefficient is going to be negative 1, and then z is going to be 1. What's the coefficient for x here? What is this coefficient going to be? What's the coefficient they're going to be? It's actually going to be 0. Okay, that's kind of like a placeholder. My coefficient there is going to be 0. My coefficient is going to be negative 2 and a 1. Negative 2, negative 3. What's my coefficient here for z? If I was going to put in z, what would I have to put in front of it? I'd have to put in a 0, right? That's like a placeholder. There aren't any z's, so that coefficient is going to be 0. All right, so I'll plug these in. I've got 1, negative 1, 1, 0, negative 2, 1, negative 2, negative 3, and 0. Oops, I lost my 0. So that's A. B is going to be 2, 2, and 1/2. Like that. 2, 2, and 1/2. Super awesome. And now I just got to stick it in the calculator and go to town, as it were. So I've got to stick these in. So I'm going to put in a 3 by 3, 3 by 3, 1, negative 1, 1, 0, negative 2, 1, negative 2, negative 3, 0. And look at. I'm going to put in my B. I'm so close to an answer. I can taste it. I don't have to like cuss at my paper or anything. I just gotta put in the calculator. Now you're gonna run the problem. Put it in wrong in your calculator. There's just no hopes. You actually have to put it in right to your calculator. Garbage in, garbage out. Okay. So now I want to say, what's my equation again? So which comes first, the A inverse or the B? The A inverse always comes first. If you get it out of order, you're going to get the answer wrong. Make sure you understand this. If you get this out of order, you'll get it wrong. Okay, that was super fun. All right, so I've got A inverse times B. Look, it's my answer. Can you hear that? Can you hear when I whisper? I said, look, it's my answer. It's so exciting. That's my answer. That's my X, Y, and Z. It's just there. Look, X, Y, and Z. It's so fantastic. There are no words to describe how fantastic it is. It's just super, super awesome. So I want to convince you of this. So let's go ahead and do our check. And the reason I want to do this is I want to show you what happens if you get it in the wrong order. So I have X minus Y plus Z was 2. That was one of them. So that's X. I'm just going to do it all. I have 0.5. X minus negative 0.5 plus Z. Is that equal to 2? 0.5 plus 0.5 plus 1, and that's equal to 2. All right, so that one worked. Then I have, let's see, where's the rest of this? I have negative 2y plus z. And honestly, since it took you practically no time to solve this problem, go ahead and check it, because what if you plugged it in wrong and then you got this problem wrong on a final exam, and that would be very, very painful. So I'm going to say, is that equal to 2? Negative 2 times a half is positive 4. Wait a second. Now I'm scared. What did I do wrong? I know what I did wrong. I can't multiply. Let me... Negative 2 times 1/2, and the 2's cancel out, and I get positive 1. See? Yay! Or you could get the right answer and then convince yourself it's wrong, if you're crazy, as I tend to be by the end of the lecture. Woots! Negative 2x minus 3y, is that equal to 1/2? So I've got negative 2x, so negative 2 times a half again. Let's see if I can do that when the time comes around. Times negative 0.5, is that equal to 1/2? So I've got, that's negative 1 plus 3/2. Is that equal to negative 1/2? No, positive 1/2. Is that equal to positive 1/2? Yes. All right, so I checked it, and it works. Okay, so this is our answer. This is our answer. Now, what if we accidentally try to put this in backwards? It's actually kind of cool. Say I try to put in b times a inverse. See what happens? I get an error. Okay, so it's kind of nice in that if you do put it in backwards, it's gonna figure it out. But if you get something like that, it either means you put your matrices in wrong, or you're trying to solve the problem in the wrong order. So it's kind of nice that you've got this fancy little check in there for you.